Hey, hi everyone. This is Sai from Let's Upgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
Hello everyone, welcome in. Grab a seat, get comfortable. This is your new session. We are going live now for the next 2 hours. We are going to take a ride on the title of AI agents. Okay, this is your day one. From what they are, what they think, how they think. Okay, this is the main core discussion that we're going to do today. I want you to notice something already. I did not call this introduction to artificial intelligence, and I did not call it introduction to machine learning either. I called it AI agents because that is the part of the AI that is genuinely changing the world right now. And that is the part most courses do not teach you well. So, whether you have never written a line of code in your life or you have already trained few machine learning models, maybe in your college projects or in your work, you're in the right room. We are going to start from absolute zero, assuming nothing. And by the end of the 2 hours, you're going to walk out understanding something that 90% of your peers, even when doing the computer science or data science degree jobs, are still genuinely confused about. So grab some water, silence your phone, and let us continue on this journey. Okay, let me move through my slides now. All right. A quick hello before we dive in. My name is Gaurav Deep. I work as a senior AI ML and Gen AI lead engineer. I have spent the last 5 years building real world AI systems, the kind that actually run in production and not about something that is just doing simple notebooks, right? It's not just academic projects, not just notebooks that look pretty in the college rooms, right? These are real systems and real users. That matters because everything I'm going to teach you today is filtered through what actually works in the real world, okay? Not just what looks good on the paper or in research papers for now. It could be white papers. Now look at the right side of the slide. Okay, so there are four check marks, which I promise you. Okay, number one, define AI agents as a buzzword. Okay, you will be able to define what AI agents are after you have completed this session with me. You will be able to identify the four core components, okay, of how AI agents work. So these four will be the core idea of what AI agents is supposed to work. Okay, you will be able to recognize agents in everyday apps. Okay, you will be able to, so you'll be a little annoyed at how obvious they were, but then you will realize, oh, okay, so whatever I look at, work with are AI agents everywhere. Okay, understand the techniques behind them. So that is interesting. So if by the end you cannot do any four of the things, do let me know because I'll fix it. And for now, let us move ahead and see this journey in picture. So today's roadmap. So our roadmap is here. For the next 2 hours, we got three modules to focus on. We will start the strip away the hype and make direct meanings out of it. What are agents? That will be the first thing we do. Next will be the module 2. Okay, we crack open the agents and look at the four components inside them. This is the most important part, actually the most important module of the day, I would say. Okay, because the mental model you pick up here is going to stick with you for years to come now. Then a short 5 minute stretch and recap we will do, because honestly, your brain will need that after 30 minutes or 40 minutes of dense session that we take. After that, module 3 is all about the reinforcement techniques or the AI techniques, how to make actually agents better. Okay, so machine learning reinforcement, NLP, and planning, these are few techniques we'll talk about. Okay, and then we will close the session with some wrap up areas, and I'll help you also put your questions in comments. Okay, if something does not click, raise your hand in the chat, give us a comment, give us so this is a live feed running in. What you can do is you can like the video, you can share, subscribe us. Okay, at the same time, if you have any doubts which you have, you can put it in the comments of this video itself. Okay, so remember, when you are viewing this session, uh, I will be available as a backup support, but this session is already recorded for better streamline experience. Okay, we need to ensure that the networks are top notch, so we will not take the risk of me being live and I might end up losing network here and there, reducing the impact. Okay, so this is a recorded session running throughout, so make sure if you have any doubts, if I'm not capturing that, it is because I'm not there live with you, but I'm there in the comment sections with you. Okay, so if you have any doubts, please feel free to put it in the comment section. Maybe in a day or two I'll get back and reply to you. So I usually come back and see the content and the questions that are coming up on it. You can reach out to me either on LinkedIn. You can try to connect with me. You can connect to the Let's Upgrade team if you want more depth on whatever we talk about. Okay, so we will be more than happy and interested to fix that for you. Okay, a quick reality check before we go any deeper. So why are we even talking about agents in 2026? Why does it matter? Okay, why not just call it AI? Why not just call it machine learning? Okay, why not just call these fancy terms that we have been calling for a few years ago, right? So look at the three numbers on your screen. The agentic AI market is now in tens of billions of dollars in annual spending. I mean, you already know how much your cloud subscriptions or Gemini or ChatGPT subscriptions cost, right? That is real money companies are paying right now to build these systems. Real budgets, real teams, real products that ship every week. Roughly 70% of the new AI startups are building agents, not chatbots. Build the next ChatGPT. That's the buzz everywhere. Now everyone is racing to build agents that quietly become number one. Your email is summarizing itself. Your code is flagging fraud even before you notice. Your phone is answering spam calls on your behalf in some countries already. So here is the line I want you all to remember and maybe write down. You are not learning a trend, you are learning the new default. The skills you pick up today are going to be table stakes in the job market by the time you graduate. With that, let us learn the actual work, which is the module 1. So here we are. What are AI agents? Let's strip the buzzword. Okay, module one. And now here is a funny thing about this question. If you ask 10 people working in the AI industry today what an AI agent really is, you will probably get 11 different answers. Okay, because maybe someone will sleep and partly say that okay, maybe this is that, this is the okay, whatever. Like they can give you 100 different answers to begin with, right? So, in fact, the most funny thing happening in the market at this point is that are people are so confused, even in the domain of hiring, HR domains, that people are asking now for 5 years of experience working with maybe like fine tuning an LLM. Okay, these things have come up recently in the market. Not even 2 years or 2.5 years that we stabilized how RAG systems work. We stabilized what knowledge graph is. We are building on top of it. Okay, and there are already JDs like this, job descriptions like this: 5 years of in Gen AI, 7 years in Gen AI, experienced engineers. So the confusion is too much. The term has become slippery, partly because of the marketing hype, I will say, partly because of the field is genuinely moving so fast that yesterday definition is already out of date by tomorrow. So we all remember that we recently started with ChatGPT 3, GPT 3, 3.5, 4. We are in the domain of 5, 5.5, and so on. Okay, the systems are moving so fast Gemini models are releasing so fast. Things are changing. Like we initially had large language models. We had GPT. Then came up the tool callings. Then came up LangGraph, LangChain frameworks. Came up Crew AI, OpenAigents SDK. So much of things flowing in. Then we eval tools. We got OPEAK as a eval tool. We got LangFuse, LangFlow. We got so many different things, different matrices to trace these models, different KPIs to bring in and solve. Okay, so many things flooded in fact, everyday technology changes here and there. Then came up MCPs, then came up Google's agent to agent protocols. Every day you wake up, you see something new is coming up. You get OpenClaw, you get Claude, you get so many things that are running in the market, right? So my job is to give you a definition that actually holds up when you point at real systems out in the real world. Okay, by the end of this module, you will be able to look at any piece of the software and tell confidently whether it qualifies to be an agent or not. Whether this job that was done, this piece of the software, the way it is working, does it look like it is built on top of an AI agent or not? Okay, that's the main thing we will solve today. So, what are agents? Here is the cleanest definition you will get today. Okay, read along with me aloud if you want. AI agent is a software that perceives its environment, decides what to do, and takes action on its own to achieve what? A goal. Remember this. Read this one more time in your head. I'll give you some space. Go ahead, read it. Just capture this: perceives, decides, acts, achieves a goal. These are the four ideas. Like, those four ideas are the whole thing. Now look at the bottom of the slide. I want you to see the difference between the three words that people throw around interchangeably and incorrectly all the time. A program, like a calculator app. Okay, you press equals, it shows the answer. Boring, predictable, and completely safe. The chatbot waits for you to ask something, then it responds. It is reactive in the nature. Okay, it does not do anything if you walk away. It does not initiate, it does not pursue a goal on its own. But an agent an agent acts on its own with its own initiatives. You give it a goal and it pursues that goal even when you are not actively watching or monitoring it. That is the leap. That leap is from tools that wait for you to the software that goes beyond and does things. Hold on to that distinction, because every other thing we talk about today will build on it directly. Okay. So if the agent is defined by perceive, decide, act, then let us go through the characteristics one by one. Characteristics number one, it look at the eye on the right side, okay, of the slide. An agent has to be able to read its environment. Okay, that could be text, that could be text like emails or chat. It could be an image, like a security camera feed or a screenshot of the screen. It could be audio like Alexa, hey Alexa, are you listening? Things like that. Okay, for a wake word, or like a phone support agent could be like that, right? Listening to a customer call in real time. It could be the raw data coming from a sensor, like a self-driving car having its lidar signals throwing from the surrounding. Okay, the point is, an agent is not blind. It is taking the input, the information from the world before it decides what to do. And here is something interesting that I want you to remember. The better the perception, the smarter the agent looks to the user. Most of the so-called magic you see in the modern AI is really dramatically better perception than we had 5 years ago. Cameras got better, right? Microphones got better. Speech to text got way better. Without perception, An agent is just a glorified script running blindly. With great perception, the agent has a fighting chance of actually behaving intelligent in a messy real world. Okay, so real world inputs like test, image, sensor, APIs, anything that can be an input, that's what it receives. You don't have to spoon feed it. These are the senses of the AI agent. Okay, so without perception, an agent is blind. Characteristics number two, it acts on its own. This is the big thing. In fact, the most powerful thing. This is where chatbots and real agents truly diverge. And this is the line of what people miss mostly, okay? See, a chatbot replies, an agent does. Let me make this brutally concrete with an example. See, if we ask a chatbot that why are good restaurants, oh, sorry, what are good restaurants near me, okay? So, if that's what we are asking, it gives you a list of restaurants, maybe with star ratings, maybe with open timings, and when do they start and all, okay? That is its job to do. Now, if you ask a real agent the same question, watch what happens. Agent can pull up your calendar to see when you are actually free. The agent can check your current time zone, your current location, look for Google reviews, Zomato reviews, filter the list by your dietary preferences because the agent might remember from the last week, check with the places which are open right now, then actually book the table on your behalf without asking you to confirm in each step. In fact, like bring you some bookings which are just one step away for your confirmation now. Okay, it did not wait for you to give the next instruction also, it just went and did the job. And those actions can be called for all kind of things like sending a message, calling an API, executing a code, moving a robot arm, doing something physically through some sensors, posting your message on Slack, uploading the next reel. As long as the agent is the one which is choosing what next to do, then it does the job without the permission on every move. You're dealing, this is what you're dealing with an agent. This is when you are actually dealing with an agent. Reply versus action, lock that in. Action is what differentiates agents from a regular chatbot. Okay, now characteristic number three, if it has a goal, then it gives a destination, not just a script. Okay, look at the target with the curvy arrow flying towards into the slide. That curvy arrow is the entire point. You give an agent a destination, not just a script. Let me explain what I mean by that. If you say, book me a flight to Bangalore under 5,000 rupees, leaving maybe sometime next weekend, that is a goal to do. The booking of the flight is a goal to do. The agent figure out the path on its own. It searches multiple airlines, compares prices, okay, checks the available dates around the weekend. So now it is filtering on the basis of if the date is equals to Saturday or Sunday, only then acceptable. If the value is less than 5,000, or if, okay, first we will try to do that. If not possible, then maybe somewhere around like 5,200, marginally equal to 5,000, something around that. Okay, we will check that, compare prices, even decide to wait for a few hours if the prices drop before booking. It can do that. So you did not tell the sequence of steps to follow. You told it the outcome you want, directly the goal. Compare that to a normal program now, where you have written every line of code with if, else, first do this, then do that, then check the condition, then return this value. Programs need scripts. Agents just need goals. I hope this is clear now. This is a huge difference. This really powers, the way we talk to our junior team members. It's exactly something like that. You will tell them what you want, not how to do it. Okay, that agent will figure out how to do it. And if it does not know, by the way, it will ask you for clarifications, it will ask you for doubts, it will come back to you and respond to you just how a junior would to you. So this is the future we are building, and it is much closer than you think now. All right, the next characteristics, let's move there. Number four, And notice I said this one is optional but powerful. An agent can learn. Look at the loop on the slide which I have shown you. Okay, actions, plannings, learning, which is like the planning and the learning, the outcome, and the feedback. Okay, so this is the secret sauce behind every agent that get extremely good, scary good over time. Not every agent learns, okay, or reacts the same way, but over time you see that they start learning to react in the correct way. Okay, a simple chatbot with hard-coded rules does not learn either, but the agent that do learn improve the approach over time. Okay, let me do more of that. So let us say that I come to an agent. I tell this agent that, okay, uh, write an email to this person for me, and then the agent drafts an email for you. Okay, it takes a confirmation from you that, okay, it's a kind of email. Then we go ahead and we say, okay, no, see, this email is a bit lengthy, and this email sounds more like a robot talking to someone. So this is the kind of fixes you should apply. This is the exact kind of changes that I want in this email, and that is where the agent will get the feedback from you. So once it's got the feedback, it will go back to the perception loop. Now this time in the perception, it has your main goal, which is to write the email to this person. It has some context that you might have given him. It also has its own output that the agent previously generated. Now it has the feedback from you. Once it takes the feedback, it will go back into the planning mode. This time in the planning mode, it will carefully understand what went wrong or what feedback wants in the correction. It will take the action, modify or format again the email template, get back to you for feedback. The feedback is very well, this aligns with me. Now you can send the email, which is where the perception will go back. The agent will learn, it will plan, okay, now we are good to go. Directly take the action to send the email. Next time when you ask the agent to write the email for you, you will realize that the agent is now already taking the feedbacks from the previous interactions and giving you an email that is really useful. Okay, so that's a continuous improvement loop. Not every agent learns, but the one that do, they become exponentially more capable over time. Now I want to show you something really important. Agents do not live in this binary world. It is not either it is an agent or it is not. Okay, there is a spectrum. Look at this gradient bar which I'm showing in the presentation. On the far left we have a script, like a Python for loop script. Your first programming course that you did, maybe you realize that this is what it is, a zero autonomy. It does exactly what you wrote, nothing more than that, nothing less, period. In fact, I will be surprised to know if it did something else. Okay, move a little towards the right. What you will see, you get a bot, a rule based chatbot, like an old school, maybe 10 years from now, the kind of chatbots we had. A little smarter than script, but still it is rigid, because at the end it is a program of if, else, okay, and while and whatnot. All programming fundamentals, the script, right? It's still rigid, but it still follows some rules, some handwritten rules. Okay, keep moving towards the right. You will get an assistant, something like ChatGPT or Claude or Gemini, answering your questions. It is flexible. It understands now natural language, but it is slightly still waiting. When I say slightly, I think it is still waiting for you to give the next prompt. Okay. Now, if you move a little further towards the right, it is where you will start finding where the word agent really starts to apply. Things like AutoGPT or coding assistants that actually run the code on your behalf without asking for permissions for every line. And at the very far right, you will get a full autonomous system. which is like the self-driving cars. Okay, trading bots managing real money or real exchange. So here is a thing you need to remember as you move towards the right of the scale. Capabilities goes up, okay, so does the risk. More autonomy on systems built on AI means more things that can go wrong without you noticing them in time and stop it. We will always get crashes if you are working with AI, and you have to be prepared for it. In fact, like the best AI engineers are the one who can better prepare for these crashes. Okay, we'll come back to this while we talk about few things later in the session. But for now, yes, this is the spectrum that defines more autonomy is equals to more capability, but more risk also. Okay, let me explain an agent what it actually do to decide. Okay, so a lot of people genuinely get wrong. How does an agent actually learn, decide what to do? So there are three flavors. The first is a deterministic flavor. Same input, same output, same input, same output. Every single time, no surprises. A basic calculator is deterministic. 2 plus 2 is exactly 4. Okay, boring but completely predictable, which is exactly what you want for some problems like banking and accounting systems, right? You can never expect any error to happen here. Could be even hospitals or medical appliances, right? Second is probabilistic. The agent picks the most likely good answer, okay, based on the patterns. Of course, it has learned from the data, whatever it is. A spam filter is probabilistic. Is it true or false? Like, is it a high risk transaction or not? Is it a spam or not? It has never seen the email exactly before, but it has millions and trillions of data points, maybe thousands and lakhs of data points on which it was trained whether an email is spam or not. So it estimates based on the probability that is it a spam or not. Okay, so then it acts on the probability. That's what the goal is. The third layer is the decision making. Agents make reasons. They use a plan. They thorough examine the plan, and then they the action. They watch the result. They observe what happened, and then they decide. They redecide. Okay, through the loops, what to do next. So what to do next based on the new information. Okay, it is not a single shot prediction. It is a loop of reasoning that keeps adapting as it goes. This is the real difference. A machine learning model, it just predicts once and it is done. An agent plans, an agent acts, an agent observes and replans continuously. If you remember nothing else from this module, okay, but remember just one sentence. It is the whole feel in a single line. Agents do not predict, they plan. That's it. So, just to recap what we have been doing, we saw four characteristics, which are how agents learn, what is the goal to the agent, how agent act, and how agent perceive. To begin with, what are agents? And agents are the software that perceive its environment, decide what to do, and take actions on to achieve the goals, right? So the next time if you're preparing for an interview, you can give this rock solid answers with solid foundations on what is an AI agent with utmost clarity. You can give the example of what is a program, what is a chatbot, and what is an agent. You can dive further deeper into the characteristics like what is perception from where it perceives, how it acts on its own, how does it reach towards its goals, how it can learn with the continuous improvement loop, and you can further explain how do an agents actually decide. You can take the example of a calculator, a machine learning model, and then an agent. Okay, they don't just predict, they plan. Now with this thought, I'll give you a 2 minutes break just for a refresher, okay, because we have absorbed a lot of information. Okay, so let us come back in the next 120 seconds to move ahead. Now I'm right here available for you, but just let us take that 2 minutes of break for everyone to grasp what we have done. Okay, go back, take notes, improvise your notes, and we will continue. Okay, if you have already observed and absorbed all the content, good. So if you are new to the AI, go in the comment. Let us know that this is your first session with agents. If you have worked with the agents, you have already produced some kind of agents. Do explain us your work, whatever you have done. We'll be more than interested to even read your projects. Let your peers know what kind of work do you do, what kind of research you have done. If you're a college student, what kind of things you are learning these days. Okay, talk about it. It will be really interesting to have these conversations. All right, I think we're good to go. If you have absorbed this and you're ready, now let us move ahead. Let me give you a way to categorize agents that you will see repeated across textbooks, research papers, or even job interviews. Okay, so we do ask in interviews to freshers, explain a reactive agent. Okay, so there are three classical types actually: reactive, deliberative, and hybrid. The three important ones. Let us start with the reactive. Look at two examples on your screen. The first one is a robot vacuum. Let's call it Roomba. It does not plan a route of your house. Okay? It just gets bumped into the walls, bumped into the obstacles, then it turns 90-degree, keeps going. And over enough time it covers the whole floor. Purely reactive. Okay? Now look at the second example, a smart thermostat. The temperature drops below a set point. Okay, the heater turns on, the temperature rises, the heater turns off. No planning, no memory of what just happened yesterday, what happened before, what was the past, or what the weather forecast says, or anything. Okay, just stimulus and response on repeat, a repeat layer. Again and again, it will do that. Reactive agents are fast, extremely fast. They are extremely simple to build. Okay, and honestly, they are dumb. They are dumb in the best possible way, because for a huge number of your problems, you see, it is okay to be dumb, but the fast exact reaction is what you want. You do not need to over-engineer the Roomba into a system that builds a 3D map of your apartment. It gets the vision capabilities, the perception of depth, okay, and all sort of 3D thermal layer imaging you can do. The lesson here for future builders is that not to over engineer. Sometimes reactive agents are all you want. They do the job very well, fine. And simplicity is feature, it's not a bug, to be very honest, because the more complex your agents get, the more latency you induce. So many of the chat applications, many of the applications which require a particular input, they will mostly suffice from reactive agents. Okay, they're fast, simple, but dumb in the best possible way. Next are deliberative agents. These guys think before they act. They are smart ones. They do not just react to whatever is right in front of them, but build a plan first, the thinking layer. Then they execute the plan step by step. Okay, they build the plan first, then execute the step. Okay, look at the examples. The first one is Google Maps. When you ask Google Map for the fastest route from Gurgaon to Manesar, or maybe from Mumbai to Delhi, however you want to take it, it does not just react to whatever road is in front of your eyes. Okay, it starts with the current traffic, the current time, your historical preferences, even where you usually stop along the way, plans actions, okay, or takes maybe like a chess engine, okay, where you move ahead here and there. So what is happening even in the chess engine, the AI is understanding which move to make next, but with different possibilities like 10, 15, 20 moves. They plan ahead that if I take this step here, what will happen, if what will the next reaction, and then do probabilities. Then how Doctor Strange in that Marvel movie saw different visions, different possibilities, all permutations and combinations. They try to do it. So they are literally simulating possible futures. They're literally scoring each result and outcomes. Okay, that deliberative agents. They're deliberately doing planning a lot, and therefore they're deliberately slow. Their reaction is something that takes time. No question about it, right? It is slow. So the cost is also more to compute. They take more time, they take more RAM, they take more processing power, they take more, they induce latency. Okay, the trade-off is the classical thing, that cost of resource versus latency versus the accuracy. So save it, like, see, the goal, how to choose between deliberative agents is, number one, the problem statement you're working on. That's the most important thing. If your problem statement requires planning, if problem statement requires some deliberative agent reasoning, that's a choice. If latency and accuracy are a second layer of questions that can add in, and that becomes the decision layer, what type of agent you want to build. Sometimes, based on expertise, based on the experience, you can then also think about something which is hybrid agents. This is where most modern AI actually lives, in the hybrid zone. Purely deliberative, purely, you can say, reactive are possible, but this is the major space. Look at the Venn diagram on the screen, okay? So they take the best of the both worlds. They react fast when they need to, and they plan deeply when they have time. Self driving cars are the perfect example. They have a reactive layer that handles the immediate emergency stuff, like swerving when a kid suddenly runs into the road. Okay, you cannot deliberate for 2 to 4 seconds for an agent to think that now the kid has come up on the road. What should I do? That 4 seconds can take a life. But they also have a deliberative layer that plans the hour long routes. Okay, like which route should I plan, how should I go, okay, with all the lane changes, the turns, highway essays, they think through it. But then there are reactive layers that assign whether to take a turn right now, whether to brake, whether to do whatever, right? So modern voice assistants like Siri are a hybrid too, LLM powered agents. Okay, so you can think about it like, so sometimes when you ask them a question, they can think before answering it. It is a general question, but the question is about some application, like turn on the flashlight or play some music. Then they become hybrid in the reactive zone. Okay, because real life is honestly best of the both worlds, hybrid plus reactive. Okay, you need plan when you have to carefully design something. Okay, but you need quick reaction when things are static. So that's where the hybrid agents live, the modern voice assistants, self-driving cars, and many more examples are of the same. Okay. Quick reality check is that I want this one to be interactive, okay? Especially look at the grid of the 6 agents on the screens. These are all things we have already used, probably multiple times in the day. Voice assistants like Siri, Alexa, Google Assistant, Samsung Bixby, Netflix recommendations. That one thing that figure out what you want to watch next. Maybe crime documentary at 11 p.m. on Tuesday, whatever it is, right? A Gmail smart reply when the Gmail suggests 3 short responses to an email just got. Okay, this is an agent making decisions about what could be the probably the best reply to give. The Uber dispatch, when you book a cab, an agent decides in milliseconds which specific driver gets your trip out of all the drivers in the area. ChatGPT with browsing and tools, probably the most famous example in the world I can give today. And customer support chatbots that actually resolve queries. Okay, and they have decisions like when to hand over to a human, okay, without escalating. And these are the agents that exist. Okay, so here is my question to all of you, and I want you to shout this out, drop it in the chat, okay, raise your hand and put it in the comments, whatever works. Which one of these surprised you the most? Which one did you not realize was actually an AI agent until I said it? Let's see. Let's see what's coming in the chat, okay? All right. Yes, that's exactly the answer. They are everywhere. You have been living surrounded by agents for years now. You did not just have a name for them. Now you do. Siri, Alexa, Google, Netflix, Gmail Smart Reply, Uber Dispatch, ChatGPT tools, customer-based smartbots, they are all agents. It's a little bit annoying actually, that this was so simple, this was always here, and I've been using them in every day, in every possible way, and suddenly it becomes a new thing to learn. So these are the concepts which have existed. The only thing is they have become really popular now again because of the LLMs and the AI agents being uh, the next solution to everything. Every company now wants to build these agents, be it hybrid, reactive, deliberative, okay? But this is the buzz now in the market. And in fact, like Google Smart Reply became smarter, Siri became smarter, Netflix recommendations will get smarter, ChatGPT tools is the pinnacle, and you will see many more such examples of uh, different products now shipping with by default agentic capabilities. If there are any questions, put them in the chat. We have covered the basics of perception and action. Okay, so waiting for the doubts or comments if there are any. I'll just cover them in the chats. Remember, I'm not live here, so I'll not talk to you in the live chat, not be able to see your live chat and reply back to you spontaneously. But yes, I'll definitely look for the comments that you leave in the video itself. Okay. So just let's take a break for 2 minutes now before we start the next module, which is anatomy of an AI agent. Okay. All right. Module 2, anatomy of an AI agent, right? So we have spent the last maybe like 40 minutes talking about what agents are at conceptual level. Now we are going to crack open and look at what is actually inside the box. Because here is one thing you need to understand. I'm talking to you about the agents, okay? You can look at any agent in the world, past, present, future, immediately figure out how it works. You will be able to read a research paper about a fancy new agent system or a job description for AI agent engineers, okay? Or a startup pitch deck, whatever it is, like how we are agentic. Just mentally slot every piece into the right component. This is the kind of mental model that you will save hundreds of hours of confusion on, okay? So let us pay attention to this module, maybe even take notes. The framework you build here will last for many years now. Specific tools and model will talk about. See, models change every 6 months, but the frameworks will stay the same for years to come. Let us look at the loop at this slide, okay? This is the single most important diagram in the entire workshop. If you walk out today remembering this one image, let this be that image, okay? Because this image will conclude the components, conclude the working of an AI agent overall. Every AI agent, from a $50 Roomba that cleans your floor to the most expensive frontier models that are running on $1 million clusters, run somewhere on this loop. Perceive, reason, act, communicate, and then perceive again, round and round and round, sometimes 1,000 times per second. Some textbooks call it sense, think, act loop, okay? Some call it OODA loop, observe, orient, decide, and act. OODA. Anthropic and OpenAI sometimes call it React loop in their documentations and publications. But whatever you call it, okay, see, the structure is fundamentally the same. Take in information from the world, think about the information, do something with it, talk about what you did, and then repeat the cycle with whatever new information just came in. If you internalize this one loop, okay, you're already ahead of most of the working engineers in the field. Because honestly, most engineers code loop they are currently building, which is why their agents end up unbalanced. Really strong reasoning but weak perception, or great action capabilities but no memory. We are going to spend the rest of this module walking through each part of the loop slowly, carefully, with real examples. So, of course, you understand it deeply. So, the component one is perception. How does an agent see the world? Look at the two columns on the slide, okay? I'll show you that. On the left, the physical sensors, camera for vision, microphone for sound, lidar for self-driving cars, and warehouse robots, GPS for location, so on, okay? Temperature and all, temperature for sensors of IoT, pressure sensors for industrial agents, and whatever you want to understand, okay? Whatever you want to understand. These are some kind of sensors or robot or any autonomous car used every day. But here is the thing I want most of you to focus on. Most of you in this room are probably not going to build robots. You are going to build software into the tech industry. So look at the right column now, okay, more carefully. Digital input APIs, responses, okay, for external services, database rows for your company's data warehouse, user text typed into the chat window, web page scrapped from the internet, document uploaded from the user, could be email, inbox, PDFs, calendar entries, Slack messages, screenshots. These are the perception inputs for most of you. Most of the agents you will actually build in your career. The agent does not see with eyes, it sees with reading the data. Same job, different sensor. You don't need a camera, you don't need a mic. Your input could be a PDF, your input could be a Excel sheet, a JSON file, a database dump, okay? It's the same job, but with different sensors, right? And the better you are at giving your agent a rich, clean, and well structured input, the smarter your agent will appear to be. Okay, so garbage in, garbage out, that is the policy applicable everywhere. That age old machine learning rule is still applicable here and honestly applies even more to the agents. Garbage in, garbage out. Now, within perception, modern agents can take in multiple modalities. This is a fancy word, modality, multimodal. Okay, what kind of input actually you're giving? That's what modality means. Look at these four cards on the screen. Text could be emails, chat messages, codes, documents, PDFs. Vision, for an example, could be photos, video frames, screenshots, scanned receipts, and so on, right? Scanned PDFs. They're basically the images of text. Audios like WhatsApp notes, voice notes, phone calls, podcasts, musics, so on, right? Similarly, we could have data, which could be a CSV file, JSON dump, MongoDB dump, or any database dump, JSON responses from an API, some payloads, database rows, spreadsheets, so on. Now, here is the genuinely cool part. They did not exist 5 years ago. Modern agents are what we call multimodal. They can mix and match all of this in one single conversation. See, previously before agents, if you had to build pipelines, you had to build different pipelines, different project which handles photos, different project that handles text, different project that handles audio. Now, a single endpoint, a single model can do it for you in real time. Ideally, previously, if you were to build these machine learning models, you would use maybe a Whisper, Wave to Vec, or a deep speech model to convert audio. Maybe some OCR models, okay, some Tesseract, maybe some more models like Paddle OCR. Even before that, some different CNN-based architectures which could resolve your photos. You would need even more different models if the photos were not scan PDFs. If the photos were images of person, you would need face recognition models. You would need basically object detection models, okay, classification models. Then you would need different libraries that can read in your different data. Could be DB dump, could be JSON, and so on. This would become your pre-processing layer. In fact, like different, then you would need an aggregator layer that would pass in these values into different layers, okay? But now a single agent is the future, which is the modern agents are multimodal. They mix all this in one session, okay? So today it is the one API call cost that fractions all of this. Okay, agents stuck on text alone are already starting to look outdated in today's world. For many ML folks in the room, yes, this is enabled by embedding spaces and unified transformer architecture. For everyone else, just know that one model can now handle all different kind of inputs in one single place. One last thing about perception before we move ahead is look at this pipeline. Raw data on the left, all the way ready for reasoning in the right. Here is something nobody actually tells you in those flashy YouTube tutorials on AI agents. Roughly half of every real world agent project is cleaning up the agent what they see, okay? The data, removing duplicate entries, stripping out the HTMLs with view formattings, filling missing values with reasonable defaults, converting messy human text into a structured data, and defining the pydantic class, defining the schemas, defining the input. 50 to 60% of your project is all about this, which is the most important part. Only then comes about designing your agentic layers. See, those are very well defined things, those are very well defined frameworks. You could use LangChain, LangGraph. You could use QAI, OpenAI, Agents SDK, whatever you want to use. That's already well defined, structured. Orchestration is structured. Deliberative agents, reactive agents, hybrid agents, they're all very well there in the place. To connecting them is not the big deal. Anyone can do that. The most important thing here is making usable signals. That is the most important skill to have. This is feature engineering plus embedding generations and some stuff like that, right? Agents do not understand the world directly like the way humans do. The world has to be translated into numbers. Pre-processing is that translator, and the quality of your translation decides the quality of everything what your agent will do. If your pre-processing is sloppy, even the best models in the world cannot save you. So worth saying twice: garbage in, garbage out. Let's look at the second component, which is action. How the agents actually change the world. Look at the two columns. Physical actions on the left: robot arms grab objects in Amazon warehouse, self driving cars turning steering wheels and pressing the brakes, drones flying into specific GPS coordinates, industrial robots building car parts here and there. Okay, Tesla's assembly line, the cool example. If you are building a robot or any physical system, these are your actions. But most of you are not here. Most of you are into the software and the IT domain. So really focus on the right column. Digital actions. The agents call an API like it calls an open network connection, okay, and talks to another services. It sends an email through Gmail's API. It writes a piece of Python code and executes it. It updates a row in the database. It posts a message to Slack or Discord. It books meetings on your calendar. It translates money through payment and so on. And the bigger the menu of actions your agent can do, the more genuinely the menu of actions your agent can also hallucinate on. Okay, so that's exactly why the huge part of agents designing is the real job. See, you have to decide how much to throw onto an agent at a one time. Okay, remember, agent works with limit. You cannot throw an entire reference book of thousands and thousands of pages and ask it to do something. Maybe get better at it. Maybe break the problem into some smaller steps. Like maybe this is the entire reference book. Can you first find the section which relates to my query? Then you minimize from thousands and thousands of pages to just maybe 10, 20, or couple of pages in single digits. From there, break down the problem that can you decide a plan of action for this, then a reasoning layer to justify the action and then solve it. So this is how agents should be designed, and designing the action space, how an action is to be taken, what kind of actions are to be taken is honestly is the remaining 30 to 40% of the battle. Remember, the first 50% battle is getting the input signal clean. The next 30 to 40% of the battle is to ensuring how the actions are to be designed, and once you do it, orchestration is the remaining 10% of the work that you will do. So let's give you a cleaner mental model for what an agent can actually do today, what's possible today in 2026. Look at this 2 by 2 grid. Four broad categories of output. First, speak or write, replying to a customer question, drafting an email, summarizing a meeting, writing a tweet on your behalf. Second is execute the code, running a Python script, generating a chart from the data, doing calculation that needs real math, scraping web pages. Third, calling a tool or a API, booking a flight through an airline. Okay, these are the few things. Okay, Stripe to do payment processing and so on. Fourth, this is the one genuinely most interesting: spawn another agent. So Myrofish is an example which spawns thousands and thousands and lakhs of agents. Modern agentic systems literally create sub agents to handle sub tasks for them. Imagine you want an agent research and write a report on electric vehicles in India. It might spawn one agent dedicated to finding resources, spawn another agent to summarize it, and carefully another agent to format the final report. Another to do a fact check on whether the whole thing is correct before sending. So multi-agent system, this is where the field is heading fast. And if you are planning to join into this market, if you're planning to come here, see your spot in the future job roles, so make sure that you read about multi agents, because that is where the future is heading now. That's the landscape of 2026 where agentic frameworks are moving in. So let's take a quick break, absorb this, and then continue with further discussion. All right, now let's move to the component number three, which is reasoning, the brain of the agent. Look at the three cards on the screen. The agent's brain can be one of the three things: rule based, machine learning based, and LLM based. In fact, like one of the bigger confusion that people have, and I've seen even with developer, is that they tend to complicate the concept of agents with LLMs. See, it's like that you want to create an application, okay? So by default, you assume that it is based on iOS or Android. Why? Because that's the industry standard now. But we can create application for any operating system. It could be some lesser known operating systems. It could be for Windows based mobile phones, which don't exist now. It could be based on Samsung's Tizen operating system, which don't exist now. Or maybe some custom operating systems that we have built for ourselves. Similarly, AI agents intelligence is not directly linked that it is LLM based. AI agents reasoning can come even from rule based, a simple Python script, a simple Python program to take actions, to do predictable reasoning and predictable, you can say, conclusions. Even that could be AI agents intelligence layer. Whether it could be a ML model, a deep learning model, spam filtering from email, that could be one. But since the industry standard and the type of problems we are solving are more flexible and language native, they're expensive on the language part. LLMs become the default choice, and the agents use large language models a lot, like GPT, Claude, Gemini as the brain. Okay, and that's where 99% of the applications that you will see have reasoning layers as some LLMs. Okay, because that's the industry standard now. But it's not related as a direct rule that reasoning has to be LLMs. Okay, see, AI agents or agents is a concept irrespective of chat GPT, Gemini, Claude, irrespective of what framework you use. Based on this concept, many companies have designed some frameworks which you can use and which you can develop agents. Okay, so whatever I discussed, the theoretical part is what an agent is supposed to be, and the agents you see in practical applications are derived concepts, derived things from this theory, that okay, this is one agent that was built, but it follows all theoretical aspects and the traits and the characteristics of what agents should be. Similarly, this is the reasoning layer. Inside reasoning, there are two distinct flavors of thinking they are worth knowing about. So look at the two cards on the screen. One is what is happening in front of me. What should I do next with it? It is fast and cheap. So most of the models, like when you go to Gemini, if you go for a fast model or if you go for lighter models, they are the one that quickly start answering based on the next probability. Okay, models which require maybe planning, they read reasoning layers. What sequence of steps gets me to the goal? Okay, so coding agent that has to read the files, write some functions that depends on them, and then run and test. Here is the rule that they use. Okay, so they use planning components. So ideally, balance is the key. How much reactive and how much balancing do you want to do? Best agents do both. They react locally and plan globally. Okay, that's the main component and the most fundamental component to know about this. So reasoning, it needs memory. Okay, this sounds obvious when I say it loud, but a lot beginner agents completely skip this and then wonder why their agents feel so dumb. Without memory, an agent is starting from absolute zero every single time you hit that API. Imagine trying to have a meaningful conversation with a friend who forgets your name every 5 minutes. You ask who you are and then ask you, right? It's useless to do that conversation. Look at the three box that says, okay, short term, long term, and the world state. Okay, so short term is what did I just say? The chat history. Long term is what did you tell me the last week? And world state is what's currently true based on the calendar. So without long term memory, the agents cannot personalize anything for you. It is you're a stranger every single time you visit them. With world state memory, what is true in the world right now, your current calendar, your current inventories, your stock price, and so on. These are things that agents can bring in them, the real assistants. Okay, so depending on whatever problem you're solving, whether do you want memory, do you want it to be long term, short term, or with the world state, that's the decision I leave to your project. But this is the concept of memory, how it is supposed to work. The next component is communication. So how the agent talks back to human. Okay, look at this diagram. There are three main channels: text, chat, messaging apps, email replies. Voice could be phone call, voice assistance, real time spoken conversations. Visuals could be chart, dashboard, or generated images. Every short video is some cutting edge system. Here is something I want you to genuinely internalize, because most beginners will completely mess this up. How an agent talks back to human is half of the user experience. Maybe more than that is how they do. You could have the smartest reasoning engine in the world, the most sophisticated planner layer, the cleanest accent space possible, okay? But if the agent's replies feel cold, robotic, slow, the product will fail in the market. Good agents have personalities. They have tone. They know when to be formal, when to be concise, when to be warm and chatty. They know when to give a short tool and answer versus when to get more elaborative. Communication is not just an afterthought or an output layer you stack at the end. Okay, communication is a product design. It is a user interface. Remember that when you start building your own agents, you are not just an engineer or a brain. You are designing the personality that a human will learn to trust over time. So that's also a very important component of the agents. But communication is not just with humans. Look at this example, a network diagram on your slide. Okay, the agent is also talking to databases, to APIs, to other agents, to tools. Modern agents are team players. They sit in the middle of the web systems and they coordinate between them constantly. A single user request, find me a flight to Tokyo, book it, and then bring it on my calendar, or email to my boss that I will be out of office and order me a power adapter from Amazon. Okay, it might involve the agent calling five or six different services. So while handling errors from all of them, the rate limits and many other things. Okay, so that kind of orchestration is the foundation of what people call agentic AI systems. The AI agents is the conductor of the orchestration. Okay, so there are brand new protocols like MCP tools which can help to with this communication. So we know what an HTTP is like. HTTP is a standard for browsers to talk to web servers. So similarly, MCP is something that is a standard of protocol how agents talk to other agents or external APIs or databases. We will dive deep into all this kind of in day two when we build something like a multi-agent tool. Okay, for now, just lock in the idea that agents do not live alone in the isolation. They live in an ecosystem, and their owner, or let's say like their own capabilities involve them to coordinate with the ecosystem. Like they can talk to databases, external APIs, other agents, tools, functions, and even get back to humans. So modern agents are like team players. They call tools and they are built around the environment. Okay. So let me put everything in one real world example that touches all four components, everything that we have discussed till now in this meeting. Door Dash Dispatch. This is a company. Okay. So every single time someone orders a food on the DoorDash, like Swiggy Zomato, AI agents run their entire show behind the scene. Look at the simple flow I will tell you. Okay, so perceive, the agents, they see the new order coming in. So perceive is what they do. They see where the customer is located, their location. They see which drivers are currently nearby. They see how busy each restaurant is right now. See how long each restaurant typically takes to prepare a specific dish. They see the current traffic conditions. They see the rider, how much time it can take to reach the restaurant and from restaurant back to you. So the agent calculates all this. This is a rich multi-source perception happening in real time. Reason is given all that information, the agent calculates the optimal match. Which specific driver should be assigned for the specific order? Picking up from which specific restaurant constraints and so on. Okay, so it has many things. Then comes the action once the reasoning is done. The agent pings the chosen driver's phone with the assignment, it allocates the resource and locks it in. The agent waits for the rider to communicate back. If the rider declines, it finds the best second option, the best third option, the best fourth option until and unless the assignment is locked. It allocates the resources and locks in. Communication is the next. It communicates. It updates the restaurant table that the driver is approaching you. It updates the customer's app that see the driver has been allocated. We are giving your order to this restaurant, and the entire loop runs through millions of times per day based on millions of orders that the agents assign. This is what an agent operating at real world looks like in production. So, quick question for the ML folks: which part do you think uses machine learning here, and which part uses classical optimization? If you can answer this in the chat, more than happy to read it. Okay, so go ahead, talk to your peers, see which type of uh, ML services do you think are being used here. Okay, I'll give you some time, you can take it, and then we move ahead. All right, your turn now. Let's look at the empty four quadrant worksheet I've prepared. I wanted to do a quick exercise here. So, in the chat sections, pick anything, okay? Like, let's discuss Siri for now. Or it could be Alexa, Google Assistant, whichever you use most in your life. For the next 2 minutes, dissect it completely. Fill each quadrant with what you think is happening under the hood. So perception, what do you think? What does actually agent see or hear? Okay, reasoning, what do you think it decides? What you actually want? Okay, then what kind of action can does it take, and what kind of communication does it do? Okay, so carry that framework for rest of your career actually if you are building agents. And every agent you look at, new product launch, research papers, new job interviews, dissect it like this. Okay, four components in a loop. You will absolutely see everything uh, of how an agent is supposed to be in that project. But for now, let us see in the chat sections if you can provide an answer to this. So while you're doing this, we are almost halfway there with the session. We have quickly covered what are AI agents, how they perceive, reason, act, and communicate in order to chase the goal. Four words, you lock them in. Two agents live on the autonomy spectrum. Okay, we saw what is a reactive agent, what is deliberative agent, what are hybrid agents. Then we saw their core components. Drink some water, take a break. Okay, for the next 30-35 minutes or next 20-25 minutes are going to be the conclusion part of your next window of the syllabus. All right, welcome back everyone. So till now, we have looked at the anatomy, the four components, the loop. We have not really talked about how the brain inside the agents actually work. Okay, what they learn from the experience, how do they reason through a complicated job. Okay, so this is what we're going to talk about now. We're going to look at the four AI techniques that power the brain of every modern AI techniques that we know. Okay, so four engines: machine learning, reinforcement learning, deep into the fields right there. Okay, we'll see to it how NLP and planning are the other two components. Okay, so each one of these is deep in its field. Okay, like either you could have an NLP expert, you could have a planning agent expert, you could have reinforcement learning expert, ML expert. Okay, so we'll talk about this. This is your module 3 now. Let us begin. So module 3, the engine behind every agent. What is this about? Look at the four icons on the screen, or the four titles, which are like machine learning, reinforcement learning, natural language processing, and planning. These are the four power sources of modern agents. Now I want to say something really important upfront before we go further. These four are not mutually exclusive. They are not pick one situation. A modern agent utilizes all four of them at the same time in different parts of the loop, of course. Okay, so ML for perception, NLP for understanding, maybe for production and producing language also, planning for the feedback, all together combined. They are what makes an agent feel intelligent rather than mechanical. So we walk through them and understand how they are solving the puzzle piece by piece. By the end of this module, you will be able to look at any agent's architectural diagram and tell which engine it is running on, doing what job, That is the real skill, the skill that gets you hired in the market. Engine 1, machine learning. Look at the definition on the slide. Machine learning equals to teaching software to spot patterns from data instead of hard coding the rules. Let me make this concrete with a contrast. The old way of detecting whether an email was spam or not, okay, you would manually write rules. If the email contains word like lottery, mark it spam. If it has more than five exclamation marks in a row, if it is has a phrase like the prince, the digital, definitely spam, something like that. Okay, so it's brittle. Your logic are brittle. You know, every hacker can bypass it. The spammers change one word and your template, your rule is broken. Completely different. You show the model. So what do? You show the model tens and thousands of emails. That's a machine learning way. And then actually tell the ML model that, see, I'm not going to tell you what is spam. I'll just going to give you the assignment, you give me the output, I'll correct it for you, okay, in some supervised way. It picks hundreds of subtle signals that you would have never imagined to write rules on. Combination of words, sentences, structure, sender reputation, that's the magic. For agent, machine learning shows in two main components: the computer vision for self-driving cars, okay, speech recognition for Siri, image classification, okay. So the 2 ML power is prediction inside the reasoning step. Is this credit card transaction fraudulent? Or will the customer churn next month? What product should we recommend next? All ML calls are happening inside the agent. That's the machine learning component that agent does. So inside machine learning, there are two flavors that agent use mostly in production. Look at the two cards. One is supervised, that gives the model labeled examples. Here are thousands of email. Each one is labeled as by a human as a spam or not. The model learns the mapping from email content to label. Then later you can give it a brand new email it has never seen, and it predicts the label accurately. Some idea applies to spam detection, medical image diagnosis, stock predictions, customer churn predictions. All are supervised examples. Then there is unsupervised learning. This is very interesting because you do not have labels at all. So customer segmentation is a classical example. So for example, you have purchase history of millions of customers, and the model clusters them into natural groups like frequently high value buyer groups, occasional bargaining hunters, deal driven seasonal customers. You don't tell the model which what should be the groups. The model itself gives you classification based on the patterns hidden in the data. You give model billions of pieces of text scrapped from the internet, and it learns trying to predict the next word the over and over and so on. Because we will not go just super deep into it. Okay, we'll tell the model that, okay, this is the natural language. Can you try to stick through it? So this is how models like ChatGPT came up. Okay, they were trained on. Now, we'll not go completely deep into how supervised or unsupervised work, but that's the idea on how you can create different intelligence into the agents and how LLMs are trained based on different tasks. So, for example, ChatGPT, how did it learn to speak our language? By consuming infinite amount of data from the internet, resource, publications, PDFs, documents, uh, wherever possible. Okay. Now let me show you how an agent actually uses an ML model when it is running in production. Look at the pipeline on the slide. User input on the left. Let us say a credit card transaction comes in. Amount is 9,999 rupees. Merchant is unfamiliar. Location is a country that the user has never shopped in. The agent reprocesses, it extracts features, the transaction amount, the merchant category, time of the day, distance from the user's home location, frequency of past transactions at this moment. Then it feeds those features into a machine learning model. The fraud detection model, right? That was trained on millions of fraud transactions versus non-fraud transactions. The model spits out the risk score. It tells that 0.92, which means 92 percentage, for an example, okay, is the risk score for a fraud. Now here is the key part. The agent decides the next action. Okay, maybe it sends a push notification to the user asking for confirmation. Maybe it asks for additional verification through OTP. It notices something really important here. The ML model alone is not the agent. The ML model is just a component sitting inside the model of the agentic framework to make a real world decision and take real world actions. This is usually common confusion in the field, which I'm again and again pointing to. Okay, people conflate machine learning models and agents. They say model is the agent. No, the model is the brain and only a part or one part of the brain. Okay, the agent is the whole creature that lives and breathes, decides, and acts. Okay, so the agent has its brain that it's telling it that okay, this is 92% a risky transaction. Based on that, agent has to decide and do something. Model is not going to do decide. Model has just given you output. Model is like the dead non-living thing. It just gives you the output of 0.92. Use this 0.92 and do something. That's what agent does. Then there is the second engine into this layer, which is reinforcement learning. So now this one deserves its own careful explanation because it is quietly genuinely different from regular supervised ML models, right? Let us loop at into it and understand how it works. To understand reinforcement learning, it is about training an agent the way you would train a puppy, a dog. Okay, you do not show the puppy 10,000 labeled examples of what a good sit versus bad sit is. You give it a treat when it does the right thing. You ignore it or gently correct it. So, for example, if I have to create a self driving car, I'll not even tell the car what is clutch, brake, acceleration, and steering, whatever, right? I'll simply let the car sit on the ground. When the car is sitting on the ground, I will give it negative scores. As soon as the car touches the clutch, it gets positive score. See, the only algorithm that reinforcement learning is driven on is positive feedback. The only goal that you give this model is you have to score all positive points, okay, as much positive points as possible. So when the agent presses clutch, I give positive point. When the puppy sits down, I give it a treat. Similarly, when the model does something right, I give it a positive point. When the agent goes back and puts in the first gear, more positive points, bonus positive points. When the agent releases clutch, extreme positive points. When the dog realizes that sitting on the ground is the behavior, more treats coming in. Okay, so that's reinforcement learning. Reinforcement learning needs no labels of correct answer. It is just based on feedbacks. Okay, reinforcement learning is best when the right answer is hard to write down explicitly. Okay, more something that has to be learned from the surrounding. Okay, so the fact that think about games, robotics, dialogue agents, recommendation, hide and seek. You have to teach to some of the AI systems. Better give them a virtual environment and let them learn. It's hard to write rules, easy to score the outcome. So that's where reinforcement learning comes into picture. There is a second engine of how these agents use or are getting smart from. Okay, so the reinforcement learning loop drawn on this screen shows you the clear goal. Agent reacts to the environment, it takes an action. Based on the action, you give the reward. This is an again and again loop. If it does something wrong, it gets a negative reaction. It corrects itself, try to do something better. So, for example, if it is recommending you reels on Instagram, Facebook, YouTube, wherever you are, if the reel you try to skip within 2 seconds, if the reel you try to skip or did not like, then you give a negative feedback to the agent that you did something wrong. The human didn't watch this reel correctly. If you stick to that reel, you watch it, repeat it. The more you interact with the reel, the more positive the point, and better the agent aligns that okay, this is something that this human wants. Okay, so that's the idea about the reinforcement learning loop. Now we switch to the third engine, which is natural language processing engine. Let's look at the big quote of how NLP is helping here. Okay. Let me make the LLM revolution concrete with a clear before and after picture. Look at the sheet, okay? I'll tell you. Before LLMs, what was the scope of the NLP? So, meaning before roughly 2022, if you wanted to build an agent for a specific domain, you had to build a custom reasoning engine for that domain from scratch. Okay, so a travel booking agent needed travel specific logic. It had to be trained on travel specific data. A medical agent had to be trained on medical specific logics, medical specific data. A coding agent on coding specific logic and coding specific data. Okay, this was slow, expensive, brittle. Only big companies could afford it. Now, after LMs, everything completely changed. Now you have one general purpose model for reasoning like GPT, Claude, Gemini. They can handle dozens of different domains right out of the box. Each new task is just a new prompt you write in the plain English. Not a new model, right? Not a new training run, not a fine tuning, not an adjustment, just the base model with a prompt. This is 100x reduction in the cost and time to build a working agent. This is genuinely the single biggest shift the entire history of the AI field has seen in the entire career of AI with humans, right? 40 years of slow progress, then one technique broke everything. The reason agents are taking off in 2026 is because the cost of building one collapsed overnight. Cheap agents mean a lot of agent, okay? Lot of agent means a lot of innovation. Lot of innovation brings experimentation and explosion of new applications. You are entering the field of at the exact moment. If you're trying to make career in 2026 with AI agents, you are in the right boat. Go ahead, learn these concepts, and the market is full of opportunities at this point. So LLMs have changed everything, okay? So before LLM, that was the problem. Now after LM, this is the opportunity that is bringing in. Okay, I've already covered this part for you. So let's move to the next engine, which is the planning. Okay, I think if you want to just check this slide, it is pretty simple how LLMs powered agents work. You give a goal, LLM reasoning comes in, then action, and then observation. Okay, that's a react loop, the backbone of modern agents. Now planning, look at the headline of the slide. A goal without a plan is just a wish. This is not just a motivational post quote, okay? You would see on someone's Instagram. It is literally how agents work under the hood. If you give an agent a complex goal but no ability to plan, it just thrashes out around making random moves that do not even connect to each other, okay? So on. Planning, what does it mean? So planning means breaking a big abstract goal into sequence of ordered, doable, concrete steps. The agent figures out what to do first. So what depends upon what and what is correct sequence to be followed. Like for example, if you ask the agent to build a particular application for you, a backend engine, okay, the agent first has to plan, break down things into simple tasks like first features, what are there, the very first layer, security will come later, but first the framework, maybe fast API, okay, or Flask. Then that define routes, define schemas, define the structure. First create the structure, define the architecture of the solution. Then based on the architecture of the solution, define how many files you will need, label them, placeholders, some dummy function names, some end-to-end testing, some dummy testing, some dry testing, then writing the full code with that dry testing, and then actually running some test cases. So planning is required. The harder the task, the more planning is required, okay? So planning is also a core component of the design that you have to follow when you're talking about designing the agentic systems. So let's look at how planning actually works inside the agent with concrete example. Look at this tree on the slide, okay? Root node at the top is plan my friend's surprise birthday party. So big fuzzy goal, right? Way too abstract, like you have not given any details. So agent decomposes it into smaller pieces. Like level 2 branch is like find a venue, uh, invite guests and order a cake, coordinate the timing of the arrivals. Now, what it does is, now each of these broken down component has its own task. So agent recurses one level deeper. So finding the venue, what it does, it needs availability options along with the budget check, the price estimates, then book the chosen one and reserve it. Inviting requires drafting message, creating a list for the people to send, and then send it. Okay, so agent is taking one bigger abstract scary goal, breaking down into sub solvable problems, then breaking them down into planned set of sequential actions to be performed, and then finally reaching the goal. So this is the decomposition layer. So this is called goal decomposition, and all modern agentic frameworks like AutoGPT, BabyGPT, they even like Anthropic's Agent SDK, they are built on this architecture. Okay, the problem decomposition. So literally, this is the exact tree that they will follow when you tell the cloud to write this particular uh, program for you. Okay, so good agents are expert at recursive decomposition. Okay, so they keep on decomposing to a point that it becomes solvable. But there is the thing nobody tells you in tutorials. Plan do not survive, okay, the reality. Look at the visual. Initially you planned something, step 1, step 2, step 3 worked, step 4 failed. When you got closed, user's mind changed, API limit, or maybe like whatever it is, right? At this point, a good agent or the best agent doesn't just plan, they are planning when the world is changing around it. Even after step 1, they are checking the parameters, they're checking in the early signs, they're replanning continuously. So they notice the failures happening, they update their plan, they devise the best strategy. So for example, the Anthropic Cloud decided that we will build this component with Gemini 4 model, and this was planned. When they actually started executing the plan, they installed this model on the server. They realized that the GPU that the server has is a fresh modern Blackwell architecture, and the Gemini Gamma 4 model currently is not supporting this GPU model. So this becomes a failure. Then on the go, the agents will realize, okay, then the next suit is to use more trustable source, which is Gamma 3 models, because they are now in the market for quite some time and they are known to work. They'll go over it, run it, or maybe change some architecture, maybe not use flash attention, maybe use Triton attention architecture. So again, some complex words I'm bringing in, some extremely technical production level components I'm bringing in. But the goal is, like for example, if the agent decided that we will buy cake from this bakery, realizes on that day the bakery somehow was not working, then in the real time agent will say, okay, what is the next best option? We now only have like the next 30 minutes to buy the cake. So we cannot go for ordering, we have to go for ready-made cakes, which is a shop which fits the budget, replan and do things. Okay, so that's how the component comes into picture. So now when you combine them all, you combine them to things like ChatGPT. So modern AI platforms like ChatGPT, Gemini, Claude, or any uh, top industry, you can say agentic framework or agentic models or LLMs, which are used to design these agentic loops, they combine all four components all together. So now, what we have covered today is what agents receive, how they reason, how they act, what is anatomy, what is perception, reasoning, action, and planning. And what are the four engines: machine learning engine, reinforcement learning engine, NLP engine, and the planning engine. Now, on the day two, you will definitely want to come back because we will tomorrow we'll be building something. We are not going to talk a lot of theory tomorrow. We will cover some more theory on different aspects. Okay, so we are going to cover some doable tasks. Along with that, we will write actual code. We will see the OpenAI's agent SDKs, how we can use it, how we can literally design agents, multi-agent systems if possible. Okay, using Python. So if you're coming back tomorrow, what I will recommend is that once you are there, bring in your laptops. Bring in your laptops compatible with maybe a virtual environment and a Python 3.10, 3.11, 3.12, 13, 14. Anything will work, but make sure that you are ready to do the hands-on exercise. We will give you enough time to write along with us. Okay, run the code, do the exercise, and we'll be learning few more stuff. So take this home with you tonight. The three resources that we talked about. First, read about this entire video. So this video is available even after the live session ends. So when the live session ends, this video you can find back, repeat, understand all the components. Maybe if you want the presentation, take screenshots of this, store it with you, take notes. Okay, that's all I can tell. I'll see you all tomorrow. More than happy and excited to be there with you and write some interesting codes. Okay, so all right, we made together. We planned this to cover under the designated time, and we have clocked it before the designated time. So that's good. So now I flip the question: that are you ready to dig deeper? Are you ready to do something that's challenging you? Go ahead, try to think about. Whether can I already become proactive and see what OpenAgents SDK is all about, learn about the thing that I have talked today. Okay, go ahead and see what is a DoorDash dispatch, how does it handle all this, how AlphaGo is using agents in learning from chess. Okay, once again, my name is Gaurav Deep. Connect with me on LinkedIn if you want. Okay, so keep the conversation going out of this live session, you can reach me there. I'll be more than happy to solve your doubts, even in person. See you all tomorrow. Tata, bye bye, good night, sayonara. Thank you for logging in.